Hi everyone, this is Mrs. J, and today we're going to be using the quadratic formula. But first, please pause the video and give this warm-up a try. All right, go ahead and check your work here. So I asked you to solve this same equation with two different methods. So for factoring, we can factor this using magic x. We get x minus 7 times x minus 1 equals 0. And then you can use zero product property to solve from there. And for completing the square, remember, move your constant, find your magic number and add it to both sides. Then you can factor your perfect square trinomial, take the plus or minus square root. Here we have a perfect square, so we end up with 4 plus or minus 3. These are two numbers that we can combine. So 4 plus 3 is 7 and 4 minus 3 is 1. So you can see with both methods, we get the same two solutions. All right, I just want to review the methods that we know for solving equations and talk about some of their limitations. First, we learned how to solve by factoring. This is a great method to use. It's usually pretty quick. However, some expressions are just not factorable, so this method will not always work. Graphing, we also know to graph and look for x-intercepts. However, this method only works if your x-intercepts are nice integers, and also if you have imaginary solutions, you will not be able to find them using this method, so it won't always work for us. The square root method is also a great method. However, we can only use this method when our b value equals 0, so no x term, so it is a little bit limited. Completing the square is a method that will always work, but remember this method is a little tricky when your b value is odd. However, it will work for every equation. Now, this last method that we're going to talk about today, the quadratic formula, this is a great method because first and foremost, it will work for every single type of equation. And second, once you know the quadratic formula, it's pretty straightforward to use. You do need to memorize the formula, but from there, it's really the same process every time. So this is going to be a really, really important method to know. And if you're ever picking and you're not sure what method to use, this could be your default. You could always use the quadratic formula. All right, so here is the quadratic formula. Hopefully this looks familiar to you. So the solutions to any quadratic equation in the form of ax squared plus bx plus c equals 0, please note that your equation does need to be set equal to 0, are always going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So notice that all of this is divided by 2a. We want to make sure that that negative b is included in our numerator, and then 2 times a is our denominator. So a, b, and c, they all need to be real numbers. 0 is a real number. It's okay for b to be 0. It's okay for c to be 0. However, a cannot equal 0 because then it wouldn't be a quadratic equation. So again, this is a super important formula. You absolutely need to memorize it. There's little songs you can use to help you memorize it, but we will use this formula a lot throughout the entire rest of the school year. All right, let's give one of these a try. So first we need to make sure our equation is set equal to 0. That is done for us. For these, I also recommend listing out what a, b, and c are. So we can see a is negative 1, b is negative 2, and c is negative 8. Especially when we're first learning or first memorizing the quadratic formula, I would love to see every single person write out the formula every time. So this is something I would like to see every single person doing. And then we just substitute. From here, it's just plugging in numbers and simplifying. So we have negative b. Notice that when I simplify, I always do it with parentheses. So negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 8 all over 2 times 1. From here, it's just following order of operations and simplifying. So this gives us positive 2 plus or minus the square root of negative 2 squared is 4. Now be careful with this step. Negative 4 times 1 times negative 8 is actually positive 32. This is a step I would absolutely like to see. When people start doing too many steps in their head, that's where I see small mistakes. So just take that extra couple seconds and show out as many steps as you can. So here you'll see that we actually end up with a perfect square, 36. So we have 2 plus or minus 6 all over 2. So this is going to give us actually 2 real answers. And we do need to do these separately. We get x equals 2 plus 6 over 2, which is 8 over 2, so 4. And then we get x equals 2 minus 6 all over 2, so negative 4 over 2, which is negative 2. So you might have noticed that we could actually solve this equation by factoring. Not all equations are factorable, so I just want to remind you. But when you end up with 2 answers that are integers, it means that your original equation was factorable. But again, when you end up with this perfect square, make sure you simplify it all the way. Okay, let's try another one together. So first we need to make sure our equation is set equal to 0. So I'm going to subtract 5 from both sides. I would like to see everyone listing out your A, B, and C values. And again, let's all write the quadratic formula just so it's really cemented in our memory forever. You'll need it in pretty much any math class you take in high school. So x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5 all over 2 times 1. So always substituting with parentheses and then just showing as many steps as you possibly can. Here, 3 squared is 9. Negative 4 times 1 times negative 5 is positive 20. So again, I'm not trying to do too many things in my head. I'm just going to show every step out. And now here, square root of 29 cannot be simplified. So I know this doesn't look like a super nice answer, but this is actually our answer. And it's actually 2 answers. It's negative 3 plus square root of 29 all over 2, and negative 3 minus square root of 29 all over 2. So we do have 2 answers, and they're both real answers. There's no I in our answer. And it's completely fine to leave your answer with that plus or minus. All right, let's try another one together. So here I do need to make sure my equation is set equal to 0. So I'm going to start by, I have 25x squared. I'm going to subtract 12x from both sides. So that gives me negative 20x. And I'm going to add 4 to both sides. So plus 4 equals 0. So in this case, A is 25. B is negative 20, C is 4. Let's write out our quadratic equation. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So X equals negative 20 plus or minus the square root of negative 20 squared minus 4 times 25 times 4 all over 2 times 25. Okay, so here we get x equals positive 20 plus or minus the square root of negative 20 squared is 400. Negative 4 times 25 times 4 is negative 400. So 400 minus 400 over 50. So 20 plus or minus the square root of 0 over 50. The square root of 0 over the square root of 0 is just 0. So really that plus or minus is going to disappear whenever our radicand becomes 0. So we just get x equals 20 over 50. And then we simplify our answer to 2 over 5. So in this case, we just have one real solution. All right, let's try one more together. So here, I could just subtract 13 from both sides and to set my equation equal to 0. You don't have to do this, but I found that anytime my A value is positive, I just have a higher success rate. So I'm actually just going to add x squared to both sides. So move it to this side, subtract 4x from both sides, and then I can keep 13 positive. So any way to make your A value positive, I would just recommend doing it. You don't have to do it. You'll still get the same answer, but that's just my recommendation. It's just a habit that I have gotten into. Let's list out our A, B, and C values. And let's write our quadratic formula. I know it's a little tedious, but I promise you it will pay off to write it as many times as you can. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x equals 4 plus or minus the square root of positive 16. And then here, negative 4 times 13 is negative 52. So we have 16 minus 52 all over 2. So that gives us 4 plus or minus the square root of negative 36 all over 2. And now we need to simplify our radical. So remember, whenever we have a negative on the inside, we put an I on the outside. And we know the square root of 36 is 6. So we have 4 plus or minus 6i all over 2. Okay, so these two terms we cannot add. You can't add a real and an imaginary term. We would leave it like this. However, there is one thing we can do to simplify. Both terms in our numerator are divisible by 2. So to have a simplified answer, a fully simplified answer, we actually do need to divide both terms by 2. So we'll have 2 plus or minus 3i. So here we have two answers, 2 plus 3i and 2 minus 3i. These two answers are complex. All right, now I have one for you to try on your own, so please pause the video and give it a shot. Go ahead and check your work here. Please make sure that you set your equation equal to 0 before you use the quadratic formula. Make sure that you are showing every single step. I want to see at least 2 steps here before you get to your final answer. And here you cannot simplify the square root of 89, so this will be our final answer. Well, our 2 final answers. All right, here's another one for you to try on your own, so please pause the video. All right, check your work here. So again, I added x squared and added 2x to both sides to make my a value positive. You should get the same answer even if you subtracted 5 from both sides. So here's my a, b, and c values. You can see that I substituted everything into my quadratic formula and simplified just one step at a time. Here, remember, if you have a negative inside your square root, it makes an I on the outside. And then here, if both of your numbers in your numerator are divisible by your denominator, you do need to simplify a little bit more. So we have negative 1 plus or minus 2i. Okay, the last thing we're going to talk about today is a specific part of the quadratic formula, which is called the discriminant. So the discriminant is b squared minus 4ac. So this is the discriminant. And you'll notice that this is the expression that's inside the radical in your quadratic formula. So I do want to point out that the discriminant does not include the square root. It does not include the plus or minus. It's only the inside. It's b squared minus 4ac. So why do we care about the discriminant? Well, the discriminant can tell us 2 things. It can tell us how many solutions to expect, and it can also tell us what type of solutions, whether they're imaginary or real. So there's 3 options for what your discriminant could be. It's very possible for your discriminant to be positive or greater than 0. So if your discriminant is positive, think about it, you have the plus or minus square root of a positive number. So because of the plus or minus, you get 2 solutions, and because it's the square root of a positive, you get 2 real solutions. So graphically, it would just be a normal parabola that crosses your x-axis twice. Now, it's also possible for your discriminant to equal 0. So if your discriminant is equal to 0, then you have the square root of 0, which is 0. And if you have that scenario, the plus or minus really disappears because adding 0 and subtracting 0 does the same thing. So in that case, since there's no more plus or minus, you only get 1 solution, and that solution will also be real. The only time you get imaginary solutions is when you have the square root of a negative number. So if your discriminant is negative or less than 0, you will get 2 because of the plus or minus, and then you'll get 2 imaginary solutions because you're taking the square root of a negative number. I do want to point out that imaginary solutions always come in pairs. So you will never see just one imaginary solution. It should always be two, and they should always be conjugates, meaning you have like plus 4i minus 4i. And then graphically, this is just a parabola that does not cross the x-axis, so it has no x-intercept and therefore no real solutions, but again, two imaginary solutions. All right, so now let's see if we can use what we know about the discriminant to look at three different equations and determine the number and type of solutions to expect. So for part A, it may help if you list out your A, B, and C values. So A is 1, B is -6, and C is 10. And remember, our discriminant is b squared minus 4ac. So if I just substitute those values, I have -6 squared minus 4 times 1 times 10. So that gives me 36 minus 40. So I get a discriminant that is negative. I get -4. So that tells me that we have two imaginary solutions. All right, let's take a look at part B. So again, my A value is 1, my B value is -6, but this time my C value is 9. So if I substitute -6 squared minus 4 times 1 times 9, here I get 36 minus 36, which is 0. So when your discriminant is 0, that tells you that you have one real solution. And then for our last one, A is 1, B is -6, and our C value is 8. So we have -6 squared minus 4 times 1 times 8. So 36 minus 32 is +4. So since it is positive, we have 2, and they are both real solutions. There you go. All right, so now we're going to see if we can apply this knowledge that we've learned in this lesson. So one of the most common applications of quadratic equations is modeling a dropped object or a launched projectile, and it models the height of that object over a given interval of time. So here are two formulas that we can use to actually create the models. This first one is for an object that is simply dropped. You're holding it in the air and you just let it go. Here we are assuming that we are on Earth because this equation takes into account the force of gravity. So we have h, which is the height in feet. For this specific model, it does need to be modeled in feet. So it's -16t squared, where time is modeled in seconds, plus s sub 0, or you can call this s naught. And this s naught represents the initial height also in feet. So if you set up the equation, you could plug in any value for time and you could see what the height of your object is. And then this next model looks very similar, except it has this extra term. This is for an object that is launched. So we still have -16t squared, the same units for the height and the time. But here we have this v naught times t. So this v naught is the initial velocity in feet per second times time. And then we still have that initial height at the end. So you can plug in values given to you depending on the context of the problem, and then you could use that to help you model, make predictions, or answer questions. All right, here's the last example we're going to try together. So this says a softball player throws a ball into the air. The ball leaves the player's hand 4 feet above the ground and has an initial vertical velocity of 30 feet per second. So just looking at this, there's a couple things that I can notate right off the bat. It leaves the player's hand 4 feet above the ground, so that's going to be the initial height. So we know that S naught is 4, and the units are correct. It does need to be in feet. And they tell us that the ball is thrown with that initial velocity of 30 feet per second. So that is going to be that V naught is 30. So if we want to create the model, we will use this starting point from the last slide and simply substitute the values we know. So -16t squared plus 30t plus 4. So this is going to be the model we use. Again, we can plug in any t value, and we can determine the height of the ball after that many seconds. So here the first question is, does the ball ever reach a height of 25 feet? So they're saying the height is 25 feet. So we're wondering, if we plugged in 25 for h, would we get a real solution to this equation? So let's try it. So I'm going to plug in 25 for h. And I'm wondering if this would give me, again, a real solution. So I know if I'm solving a quadratic equation, I'm going to set it equal to 0. So in this case, we don't even need to actually solve. We just need to know if we have real solutions. So what can we use to determine if solutions are going to be real or imaginary? We can use the discriminant. So we see that our a value is negative 16, our b value is 30, and our c value is negative 21. And remember, the discriminant is at b squared minus 4ac. So we have 30 squared minus 4 times negative 16 times negative 21. And that gives us a discriminant of negative 444. So because our discriminant, negative 444, is less than 0, that tells us that we will have two imaginary solutions, which implies that we have no real solutions. And when we're doing a real life problem, we only care about real solutions. So since plugging in a height of 25 doesn't yield any real solutions, we know that the ball will never reach a height of 25. So that means that the answer to this question is no, it does not reach a height of 25 feet. Now, if we plugged in 25 and our discriminant was 0 or positive, that means that we have at least one real solution, so we would reach a height of 25. But again, here our discriminant is negative. Now this part B says, assuming nobody catches it, so this is a separate question, but for the same scenario, how long does it take for the ball to hit the ground? So we have to think about this. It's not saying this explicitly, but if the ball is hitting the ground, that means the height is 0. So they're essentially saying, what is the time when the height is 0? So I'm going to replace h with 0 and use that same formula, that same model we created, and I'm going to solve. So our equation is already set equal to 0. So here we can just go straight to our quadratic formula. C equals 4. Okay, so this case it's t instead of x. So we have negative 30 plus or minus the square root of 30 squared minus 4 times negative 16 times 4 all over 2 times negative 16. And now we just need to simplify. So negative 30 plus or minus 900. Be careful with this next step. It's plus 256 over negative 32. So these negatives will both cancel out. So t equals 30. Again, I'm canceling out my negatives. Plus or minus the square root of 1,156 over 32. Now at this point, because it is a real life problem, it would actually make more sense for us to plug this into our calculator to get decimal approximations. Because if you told someone this many seconds in real life, that wouldn't make any sense. We would like a decimal approximation here. Now in this case, it actually turns out that 1,156 is a perfect square. If it's not, that's totally fine. Again, it's okay to have a decimal approximation. But here we have 30 plus or minus. The square root of that number is actually 34. And again, you can just use your calculator to help you with that. So then if we do 30 plus 34 divided by 32, that is 2 exactly. And then if we do 30 minus 34 and then that divided by 32, we get negative 0.125 seconds. Now, if you think about it, because we are working with a real life problem where t is the number of seconds that have gone by, it does not make sense to have a negative t value. So this, even though algebraically we did it correct, this is not a solution that makes sense for the context of this problem. So that means that our only solution is 2 seconds. So that is how long. We want to make sure we always include units with our final answer. That is how long it would take the ball to hit the ground. So you could see here that depending on what you're asked to do, sometimes all we need to do is use the discriminant to see if we actually get real solutions, or sometimes we will be solving all the way through. And again, for a real life problem, it is completely fine to have decimal approximations as your answers if that's how the problem turns out. All right, so that is all for today's lesson. Thank you so much for watching.